Hello, my name is Sam Alm, and I've been in quarantine for 7 days. As I can't leave the house, I'll be using Flight Sim 2020 to demonstrate the aerodynamic concepts of stall. As the angle of attack increases for an aircraft, lift will increase to a certain point before beginning to decrease. This corresponds to an angle of attack known as the critical angle of attack. This decreased lift is caused by flow separation, which is caused by an adverse pressure gradient causing vortices and turbulence due to a negative velocity profile near the boundary layer. This is caused by the velocity reaching a maximum near the top of the airfoil. From the cutout condition, we know that the velocity above and below the airfoil will be equal at the tail edge of the airfoil. Thus, the velocity will be decreasing over the edge of the airfoil, and we know from Bernoulli's that the pressure will be increasing. So that increasing pressure will cause a negative velocity profile near the surface of the wing. This makes climbing flight impossible and control of the aircraft very difficult. However, stall is easily remedied by pitching the nose downward and regaining lift and control of the aircraft. That is, unless you're too close to the ground to do so. Currently shown is airflow separation as depicted from an airfoil in a test chamber. It is these vortices and turbulent flow that makes it incredibly hard to control the aircraft. It diminishes lift and makes it impossible for the aircraft to climb. Because flow separation is a function of the boundary layer of the flow going over the airfoil, the critical angle of attack is actually more dependent on the Reynolds number than the geometry of the airfoil itself. The Reynolds number is defined as the ratio of inertial to viscous forces. Thus, a lower Reynolds number will correspond to more drag and larger viscous effects, which decreases the coefficient of lift. It also affects the transition point of laminar to turbulent flow, which in turn greatly affects the flow separation behavior. I hope all of you have enjoyed this quarantine look at the aerodynamic phenomena of stall, and stay safe out there.